Hello everyone. Just let me know whether I'm at on live or not. My audio, my am I audible or not? I guess everything is fine. I guess. So before starting, let me introduce myself. Okay. So myself Vamsi. Okay. Currently working as an associate software engineer at SNSA. A software. So I'm in 2021 undergrad. And coming to this particular video, okay, if you are watching this video for the first time, then you have to you have to know about this particular course or playlist that we are doing for the past 15 days. Shafali, not today, I guess so. Today we are again, like, we started recursion, right? We started recursion on 2 days back. So today it will be last class on recursion. Okay. And then yeah, I will discuss it tomorrow tomorrow patterns. Okay, so we can see almost 10 to 15 patterns. Okay, I will take a 1.5 hour session tomorrow, 1.5 hour or 2 hour session. Then we can cover all the 15 to 20 patterns. Okay, I will tell you the logic behind the how to build patterns easily as well. Okay, tomorrow. So today we'll have a small session, okay, like 1 hour session on recursion. Then we'll close the recursion today. Okay. So is this is a recursion class 3. Okay, recursion class 3. Till now we had two classes. Okay, and in recursion 1 we have covered basics and how to build a logic. Okay, how to build a logic or thinking process of recursion. You can assume like that as well. Thinking process of recursive. And yesterday we have solved two famous problems, and one is subsets, or can be called as a power set as well. Okay, and again we have solved a staircase. Did we solve this problem, staircase? Or we have seen palindrome? Yes, we have seen palindrome for a string. So I guess this is what we have seen till now. Okay, and today we are solving follow-up questions. Okay, follow-up questions of subset or power set, whatever you call it as. Okay, and like it will be, yeah, we'll discuss the problem over there. And so yeah, yesterday I have asked you guys to look into the bit manipulation solution for this, right? Power set. Let me know how many of you have had a look at it. If not, it's okay. Okay, and let me know whether you want to discuss that as well in this particular session. So I'm happy to discuss. And if time permits, we'll see another important problem called coin change. Okay, just an recursive approach. I'm not discussing the dynamic programming solution, so I'm discussing only recursive approach here. Okay, so once while we are discussing dynamic programming, then we'll convert all of these problems into the dynamic programming. Okay, I will tell you how to convert them. It's not a big deal. So on this note, let's get started today. Okay, with today's session. So the very first problem that we are gonna discuss today is subset sum or power set sum. What is this question states that? Okay, you will be given an array or a list in Python. Okay, and a key or target, you need to figure out, okay, whether like if you add any subset, okay, if you add any subset of the given list, and if you are able to that, then the sum of that particular subset is equal to key, then you need to return true. Okay, otherwise if you are not able to find the key sum, then you need to return false. Okay, so this is the problem. Okay, so this is going to be just a follow-up question for what we have seen yesterday's class. So in yesterday's class we have seen about generating subsets, right? So this is just an like that question. So here after generating subsets, we need to figure out the sum here. That's it. Okay, so here we know how to generate subsets. This is what we know, and we just wanted to figure out this part. So how can we do this? So basically yesterday, okay, yesterday we have generated all the subsets. So one thing that you can do is, so after generating subsets, while printing the subset, you can just add up all the elements in that particular subset, and you can just check with whether that sum is equal to key or not. Okay, and there is another one, okay, which I wanted to discuss now. Before going that, I will tell you, okay, how to modify your yesterday's code to get this problem done. Okay, it is going to be n into 2 power n solution, like if you are following the approach that we have did. Okay, because to add all the elements in an subset, again you need to iterate over the list. Okay, you need to iterate over the list. So for that you required n times, right, where n will be the size of the list at max, so which is not recommendable. But anyhow, let me go and code that as well. Okay, so we need like output which is a dq, yes, which is a dq, and we are just checking if n less than 0. Okay, then we are printing, like I'm first writing whatever code we have seen yesterday. Okay, and then we need to return from here. So if that is not the case, we'll do first we'll put the whatever the value which I'm currently standing at in the list, and I will traverse. Okay, and I will traverse through it with the n-1 ls output. Okay, and after traversing by adding that element, I need to go back and check, okay, after taking that particular element out as well. So for that I will do output dot pop. Okay, and then generate n-1 ls and output. Okay, this is what we have seen yesterday to generate the all the subsets or power set of an array or list. Okay, if I call generate subsequence, so here I will be giving two size, then empty. Okay, empty DQ. Now if I pass this, I got the all the subsets like power set. Now if I add up each one, okay, if I add up each one, let's say if I am searching for, okay, let's see, if I am searching for key is equal to a 6. Okay, now just tell me, so is there any sequence that any subset which gives a sum as 6 by adding all the elements in the subset? Will I get a key element? Yes, right. So if I add this particular subset elements, then I will get a key value which is equal, right? So 6 equal to 6. So answer would be true. And if I give you like if I give you my key as 1, if I give you my key as 1, then tell me what will be my answer. again it is going to be true. So this is how I wanted. If I have given key equal to 8, then my answer should be false, because I can't generate the sum of 8. Okay, so how to change this particular logic to solve this problem? So here, if you can observe, so instead of printing the output here, if we can just check, so anyhow we are generating all the subsets, and without printing that particular like subset, I will just check if sum of output double equal to key. Okay, so I will pass key. Okay, so why I am passing here, why not after output? So basically all the default elements or default parameters should be at the right end itself. Okay, so if you give a key after output, then it will throw an error. Okay, so the rule here is, if you are having an default parameters in your function, then all the default parameters should be at the right side end. Okay, so if this is the case, what I will return, I will return a true. Okay, or yeah, I will just print a true here, and that works, right? Print a true, and I will just return this. It should work. Okay, let's see. I need to pass extra parameter. So sorry, the sum which I am looking for is 6. Let's assume that I haven't got anything here, haven't got the any output. So yeah, so now I got the true. Okay, so the sum I am searching for is 6. Okay, and it is saying that yes, there is a sum which gives you 6. Now if I give you my sum as 4, yeah, if I have give, let's say here I will change 1 to 2, and if I give my sum as 4, now how many times this particular statement is going to print? Yes, one time. Got it. This is how you guys can modify this existing code, but there is a little drawback here, okay, which I wanted to tell you. So as I said earlier, that complexity is going to be, n into 2 power n. So this n is for to add all elements in output. You might say, bro, we are using the sum now, like why should it take big O of n time? It should take only um this constant time, right? But so is that the possible, like without iterating through entire output, like whatever we have in the output dq, is that possible to sum up all the elements? No. Then the imagination, that the thing happening in the back end is going to be like iterating through all the code and adding up all. So you need to consider that timing as well, time complexity as well. So this is the problem. Okay, this is the problem with Python. So many people think that there are a lot of inbuilt functions is happening. Okay, inbuilt functions. So people think that all they don't know how exactly all those inbuilt functions are being built up and are being coded. But without knowing them, they just went to the interview and they will say, yeah, this is how I will take, I will use this, and I'm done. So it should not be the case. Okay, so interviewers know, like they don't want people who remember all those things, like memorize all the things. They want the people who learn. Okay, who can build the technique, who can build the logic. So yeah, you need to be careful while using Python. Okay, so if you are using something, then like sum, you should able to write that, like build that sum backend as well. Okay, and please make sure that you know exact time complexities as well. So yeah, don't do these mistakes while if you are using DSA for Python. Okay, know the complexities very well, time complexities. So the time complexity here is n into big O of n into 2 power n, and again the space complexity. Space complexity. I'm using an extra data structure called DQ. Yeah, so it is going to be again big O of n, right, at max. So do you think is this an efficient solution for this? So can't we reduce this one n? Can't we? So the interview will ask you to reduce this extra n which you are taking, and he will be okay with big of 2 power n. Okay, 2 power n, and again after reducing this n, then he will ask you to optimize that without like in a linear time as well, like constant, like big O of n square, which is less than 2 power n. Okay, so first as of now discuss the 2 power n solution. So how can we do this without using an extra memory, without doing that sum is equal to output kind of stuff? So what we can do now? So I will take an extra parameter here. Okay, I will take an extra parameter. So which is an which is going to be current sum. Okay, so current sum. Then I don't want this DQ anymore, since I already said I am using this guy. The value, okay, sorry. So output, okay, here it should be current sum, and here it should be a current sum. And we don't need these operations as well. Okay, so before that, let me discuss the tree. Okay, let me discuss the tree and how we are going to approach this particular problem. Okay, let's stick to the same example which we have seen a 1 2 3 list, and sum I am searching for is let's say 6. Okay, now let's first thing, let's draw the tree. Okay, what we generally do. Okay, yes, now it's okay. Now let's say you are currently standing at index 2, means a last index. So here, and your current sum is 0, and your k value. Okay, so you know key is equal to 6. Okay, now first I have only two choices, whether to take or not take. Okay, so after doing that you will be going, that's it. If you are taking, you need to add that a particular sum, like current value to the current sum, right? That's how it should work. Okay, let's say I am currently at 2 and I decided to take that value, okay, whatever there in the second index. So how it should work, then I will move to the next index, so which is 1, and if I consider this 3, then my current sum will become 3, right? Now if I decide not to pick up that particular sum, like value, then I will move on to the next guy and my current sum remains constant, which is 0. Now again I'm at 3 and I have again 3 choices, like 2 choices, like either I can pick up the first index value or not pick up. Okay, so it is going to take and it is going to be not take. And if I take that value, then it should be it should go to second index for next index for sure, and it is going to be a 3 plus 5, say, sorry, 3 plus 2, it's a 5. And if I decide not to take that first element, then my value should be it should go to next element, then the value is going to be 3 itself, like constant. And here as well. Okay, so yeah, let me come to here. So if I decide to pick up 0th index, then it should become -1 and 6. And if I decide not to pick up that, -1 and 5. So this is what I have. Now I guess like here, so -1 and 3. Okay, so if I decide to pick up the 0th element, then it should become 4, and here it will become 3 itself. Okay, now again for this, again I have two choices. I can pick up the first index. Okay, so if I pick up the first index value, then it will be 0 comma 2, and if I decide not to pick up that value, it is going to be 0 comma 0 only. And now again I have two choices for this. If I decide to pick up that, then it is going to be a 3, and if I decide not to pick up that, it is going to be 2 alone. Okay, so again I have two choices here. If I decide to pick up that, it is going to be 1, and if I decide not to pick up that, it is going to be this. Now you have all the values. So at each value, what you need to do, you need to check whether your sum is equal to a key or not. Okay, here your current sum equal to key. So whenever you found a key, then you will say print. Okay, you will say return true. Okay, return true. So true. Now here you haven't found the true. Okay, like you will return false here. So from here, from this particular index, you need to return, okay, you need to return true, right? Because you have found the value. So how does it work? So if you have, like, among all the false, okay, if you have one true, what does it mean? It means that you found the sum which is equal to the key value. Okay, so even if you have 1000 false, if you have one true, your answer is going to be true. So how can I get that? So you will do or here. Okay, true or false. It is going to be like we have seen the logical operators, right? Logical operators, or, and, not. Okay, so this are. So if you do or here, it is going to be true or false. So you will return true. So you will return true here. Now again it will go here. So here it is not, it will return false, and again it will return false, and it so false or false, it is going to be false. So here true or false, it is going to be true. Now again it will return false here, it will return false, it will return false, false. So false, false, again false. So at the end you will have a true or false, so you will return true. Okay, so this is how it works, right? And if I have given the sum is equal to, like, key is equal to a 10, if I have given key is equal to 10, then what will be my answer? My answer is going to be false, because I haven't found the current sum equal to 10 anywhere. So then my answer should be false. So this is how it works. Okay, so here we haven't used any extra memory, we haven't used any extra time to compute our sum. Okay, so now I can say that it should take big O of 2 power n time complexity and without any space, just to check whether there is an subset sum which is equal to the target sum or not. Okay, now how can we code this? So let's quickly go and do that. So let's say here I don't need this. Okay, let me write from the bottom. So at first what we need to do, so if, like, at any time, okay, at any time our current sum equal to key, if our current sum equal to 3, then what should we do? We should return true, sorry. And then what is another base case? So whenever we have come down to n less than 0, like n less than 0, then what does it mean? we are done with all the elements in a list, and there is nothing to add. Okay, so in that case we need to again check whether we have our current sum equal to key or not. Why? I will tell you that. So if you observe this particular call, now what happened, your n is less than the n, okay, less than the 0, but your current sum is the equal to the key, right? So in that case as well you need to check. Okay, it's okay, okay, so before coming as well you are checking, but again you need to check here, and if it is equal to the current sum, if it is equal to the current sum, what you need to do, you need to simply return true. Okay, and if it is not equal to true, okay, you should return false, because you have visited all the elements but you haven't found this sum. In that case what you need to do, you need to return the false as well. Now for all other cases, what you need to do, you need to traverse to the all the elements, like you will be having two choices, whether you can pick up that particular element or you should not do that. Okay, so for that, let's say left. Okay, so I'm traversing to the left subtree. Okay, so while I'm traversing to the left subtree, then I'm picking that guy, right? So else, then key, so my current sum will become current sum plus whatever I'm currently standing. Okay, and my right value is going to be n minus 1, and a list, a key, and current sum. So I'm not adding anything to the current sum now, because I'm not taking that element. If I'm not taking that element, why should I add? So at the end, I will simply return uh, the R of the both the choices I have. Okay, now I will go, yeah, now I will go and store this thing in an answer, and at the end I will print answer. So if my answer equal to true, it means that there exists a sum. If my answer equal to not equal to true, then it means that there is no subset which is equivalent to the sum of a key. Okay, there is no key sum. Okay, now let's execute this. In this case we should get a true, and if I have given a negative values as well, it should work. Okay, -3, -4, -5. Okay, now I am searching for the sum of -7. Okay, now it should return true. Yes, we got the true. It means that it works. Okay, it means that it works. So here if you observe, the overall time complexity is going to be only big O of 2 power n. So 2 power n means we will, for each element we will be having two choices. Okay, so at the end if you have n numbers, then it is going to be n 2 power n choices. Okay, so hope you have understood, and let's go and solve another problem in this similar fashion. Okay, so which is called as an coin change problem. Coin change problem. What does this coin change problem means? So if you know, please let me know in the chat. If you don't know, it's okay. So you will be given an coins. Okay, you will be given an coins. Let's say you will be given 2, 5, and 10. Like it can be any numbers. Okay, it doesn't mean you will be getting only actual denominator. Okay, so you will be given any numbers like 1, 2, 3 as well. Okay, and you can assume that each coin is supplied for infinite number of times. Okay, like you have n number of coins. Okay, you can have infinite supply of the coins. Now you need to find the money you need to figure out the money for an a given element or given money. Let's say a number of, okay, let's say if I have given at 11, if I have given my money as 11, you need to return how many ways, how many ways I can generate the money. Okay, how many ways I can give the change to the person. Okay, in simpler words. So here, how can we do this? Like, let's say, let's try to understand what problem statement exactly do. So if I am searching for 11, okay, and I have all these coins, what is the one way I can do? What is the one way I can do? I can take 1 rupee coins, okay, 11, so it is going to be 11 rupees. Done. And what is another way? So I can take a 2 5 rupee coins, okay, 2 5 rupee coins, plus I can take 1 rupee coin, it is going to be 11 rupees again. Yes. Now if I take 1 5 rupee coin and 6 1 rupee coins, then it is going to be again 11 rupees. Now what is another way I can do? I can take 1 10 rupees coin and 1 rupee coin, then it is again going to be 11. So now for this, is there any other way that we can do? No. Okay, so for this particular money and for this particular coins I can make 4 ways. So 4 ways net change. So this is the problem statement. Okay, just think, okay, how can we solve this particular problem? So here the important point here to be noted here is you will be having infinite supply. Okay, infinite supply of coins, infinite supply of coins. Now think, okay, so you can just try to relate this particular problem to the like earlier problem. So if I have given question like there is no infinite supply, you can choose only one coin at a time. Okay, if I told you you can choose only one coin at a time, then what would be your answer? So there is only slight modification to the earlier problem. Okay, to the earlier problem.